Oh, I had forgotten to record the meeting. Now the meeting is being recorded. Yeah, so as I was saying, the first exam is on the 11th of February, and we will have it on D2L. There will be two parts to the exam. One will be multiple choice, multi-select, true, false kind of questions for about 50 points. And then there will be two programming questions requiring you to write multiple classes and or interfaces and implement some functionality, and you need to submit Eclipse Java projects just like you submit assignments. That would be the second part. Anything that we have done in this course, starting from the first lecture through whatever we are doing tonight, would be fair game for the exam. So that is the exam next week, and you are allowed to look at the web. You can look at the book, you can look at notes, you can look at the text, you can look at anything, but you are not allowed to send email, you are not allowed to talk to anybody about the exam or anything of that kind. That is the only restriction. So it has to be done by you. You cannot ask anybody for help. Then the other thing is we need to talk a little bit about the topics for tonight. Let me get my writing material here. So what I want to do is talk about two things. One is a subtle issue regarding the singleton pattern and some reinforcement about the adapter pattern. So let me go ahead and start sharing my screen. Okay, the first thing is let's talk about the singleton pattern. Oops. Okay, so if you write let me write some code here. Let me get this to move. Okay. Public class, my class. And if you want this to be a singleton, the most appropriate thing to do is to put in a private constructor. I'm not able to get this, move to the right anyway. So what you would do is put a private constructor here. And if that is the only constructor that you have, no one can instantiate an instance of my class because this is private. So from the outside, nobody can create an instance of this. So what we have is a static method, public static my class instance. And what we do is if, okay, let me go ahead and put some space for this method, and then I will complete it in a minute. What we will have is here a private static field of type my class, and we write here if my class is equal to null, we create an instance of my class here. and return my class. So if this is your code, then somebody can write my class.instance. And what will happen? If this field is null, which would be the case when we load my class into memory, if my class is null, the instance method creates an instance of my class and returns that. And all succeeding calls will have my class not equal to null, so it will return the only instance of this class. So that is how this works. Without this method, you cannot really have an instance of my class created. So one of the questions was saying what kind of a access specifier you should have for the constructor. The correct answer in general is private. If you don't have it private, you are going to be in trouble, because if it is public, for example, anybody can instantiate my class. You can have many, many instances. If it is protected, then you can have the subclasses create instances of this. But if you make it protected, there is a way to escape this by putting final here, which means this class cannot be subclassed anymore. So if you don't want subclassing, then this might be an option for you in Java, but not in general in any programming, in all programming languages. So if you make a class final, then it cannot be subclassed. So subclasses will not exist. So they will not be able to create my class. But again, there is a catch. In Java, if you have a class with a protected field or method or constructor, it can be accessed by that field or method or constructor can be accessed from code within the same package. So to take care of that, you will need to put this into the same package as into a single into a package that nobody else can become a member of. Those are making really huge constraints. So in general, you should have private. Okay. Are there any questions about this? Anybody?
I have a question as far as, so when you you have a static class that if it's null, it creates an instance, but would you have to use this within a subclass for, because just looking at the code, like my class doesn't really contain any information other than if it's there or not.
Are you talking about subclassing this, or are you talking about other members of my class?
I suppose I'm just trying to visualize, because like you wouldn't have it as a final class, so you could use it as a subclass.
It's okay, you can subclass it. Yeah, usually you won't make classes final, right?
Okay.
So if you make this as, of course, you can have all kinds of methods here, by the way. If, for example, public void do something.
Got it.
Right, that you can put. But I still haven't answered your other question regarding subclassing, right? So you can put lots of stuff here, but then there is only one object of this type. But the question is, how do you subclass this? That is dealt with in the slides and in the book and in the lectures. What you do is you write public class, your class extends my class, but then it will not compile because this has a private constructor. So what you need to do then is put a protected constructor protected my class. Right. Then this can be accessed from the subclasses. So the subclass will be able to use this constructor to create an instance of the subclass. But then the problem is the subclass will be able to instantiate objects of type my class. So we have more elaborate mechanisms to check what type of object is being created. So we need to have, also we need to distinguish between these two. So we put a dummy, maybe I can put dummy here, right? And we will put one or something here. This is simply to distinguish between these subclasses. And here you do check the type of object. If it is my class, or an exception. So you would say throws exception here. This way, subclasses will not be able to instantiate my class directly. So that is the fix for that. Any questions?
That's helpful to see you explain it like that. Thank you.
Okay. Now, let's see. I'm not sure that I have anything more regarding singletons, but I want to spend a little bit of time on the other pattern. Or there are four. I think you have seen 4 patterns this week. The other pattern that I want to talk about is adapter. Okay. So let's talk about adapter. Well, what is an adapter? All right. You are about to build a class. Somebody gives you an interface saying, okay, you have to create a class that implements all the functionalities called for by that interface. So we have an interface. You're given an interface. Create a class for it. Right. It will be like some of the assignments that you have seen in this semester, or in 240 you did a lot of collection classes, and then you were asked to maybe create a collection class that uses linked lists, that is, use those references to put nodes one after the other, or use arrays or whatever. And you have to spend a lot of time starting from scratch, writing the array declaration, having a variable to keep track of the number of elements, etc., etc. And that takes quite a bit of coding, quite a bit of testing and debugging. And ultimately, of course, the purpose of doing that is to learn the material. But if you do that in practice, if you try to, you should start doing those kinds of collections in practice, you are basically reinventing the wheel. For example, there are lots of collection classes in Java. You are much better off using those collection classes. But what happens is very often you want a collection class that is very tailored for your application. Okay, maybe you are having a collection class for courses and courses in a university, and then you are focused on the functionalities that you find in a university, and then you don't just want the kind of general methods in array list or linked list that you find, but you can use that as a crutch. You can use it to carry out your functionalities. So you would use things like array list from java.util or linked list or vector, or there are lots of classes, all right? So you would use those things to get a speedier implementation of your class. By the way, I just gave an example of a collection, but it doesn't have to be a collection. It can be anything. And then what you do is you look for something that you can use and get your job done more quickly, because you want to be productive. So you are trying to reuse existing software. One of the options is, of course, to copy all the source code of linked list or array list into an Eclipse file and then try to modify it. But that takes a lot of effort. You need to understand somebody else's code. And if that uh, is your attempt, you will spend a lot of time doing that. Maybe you're better off actually writing code from scratch than understand somebody else's code. And any modifications that the other person makes to the code, you will not see because you have already copied the code. So what you do is you create an instance. So let me go ahead and maybe draw a little picture here. What you would do is you will create a class. This is your class. So let me again call it my class. And suppose you are using array list to speed up your work, you will create an object of type array list. So maybe call it list or something. So that array list is existing here. And you have a lot of methods here. And whenever you want to add or remove or search or whatever else you have, you are going to do this on the array list. You may have methods that say that things like remove all courses created before 1975 or those kinds of things, I mean, which are not to be found in array list. But for that, you are keeping all the courses in this array list, and you will have some loop or whatever to look for those old courses and remove them. But you don't have to reinvent the idea of or reinvent the functionality of removing an object, searching for an object, etc. You are more focused on problem solving, on your application related problem solving aspects. So if you want to know the number of elements of the collection, you will ask this list, what is your size? And that you will return as the number of elements. So you will have a bunch of methods, and most of them would use this list object to carry out the functionality. This is called an object adapter. You're putting this list as an object within the class. And this is called the adaptee. You're using array list as an adaptee, and this whole thing is called an adapter. My class is the adapter, and array list is the adaptee. Okay. Questions about that? Okay. The second type of adapter that you have is called a class adapter. Okay, let me motivate that from an actual thing that I had to do recently. I was writing a pretty big application with a graphical user interface. This really happened. And I had a few text fields here. You have used text fields in the second assignment. I had a bunch of text fields, and the code was quite long. And I was kind of disappointed that I didn't foresee certain issues. What happened was, if the user did not enter anything in these text fields, if they left these empty, my code was crashing. I was not checking whether things like this, text field, my field, I'm not following the conventions here. I just want to write this quickly. New text field. If my text field is this, and if the user doesn't enter anything here, I would write, I need to check if my field dot get, if my field dot get text is not equal to null, then do something. Otherwise, if you try to access the contents of this, you get a crash. If you try to get a number that is stored here, for example, in the text field, you'll get a crash. And I didn't really want to change or add all these checks. So what I did was something totally different. What I did was I created a class. I don't remember what I called it. Let me call it my text field. Extends text field. Okay. So because of inheritance, my text field will have all of the methods of text field inherited straight. So all the fields, all the methods, everything is part of my text field. And what I did was this: public, I put an override here, public string get text. You might recall that text field has this method get text to get what is stored in that. What I did was this: if super.getText is equal to null, return, I just returned, I think, one space. Else return super.getText. So this way, when the user calls, or let me backtrack, instead of declaring text fields in my program, I changed them to my text field. It was a very simple edit. Everything worked perfectly. So wherever text field occurred, I changed the type to my text field. Now, when the user called get text, or actually it was my code, when it called get text, and if there was nothing in it, in that text field, it would return at least one space and my code stopped crashing. This took me about 5-10 minutes, and I didn't have to do all of these checks all over the place in my code. There was so many places in my code that I had to change. So this helped me a lot. This is called a class adapter. You are subclassing an existing class. Text field is the adaptee. My text field is the adapter. So you're subclassing the adaptee. You're exposing all the methods of text field, but you are overriding one method that I wanted to have a slightly different functionality. I don't need to write any of the other methods because they are all exposed because of subclassing. So that is where you would use, that is an example of where you would use adapter as a class adapter. Questions? Okay, if that is the case, let's stop recording. So don't forget the exam next week and be here promptly at 6. And please use the class meeting. I have put it as the first announcement on the D12 page.